Hello everyone, um, Sigita here, and welcome to our first lesson on functions. So what we'll be dealing with today is quadratic functions, and we've got a very nice question here that says, well, as you can see, the figure shows here some graphs, right, or some functions, and both these functions are quadratic functions. So what I did was I color-coded the function as well as the name of the function. So for instance, f is blue. So the blue function is f of x, and g is red. So the red function is g of x. Now we are given here that f of x is x squared, and we are also given that g of x is this very complicated equation over there. And what they want is for us to determine the coordinates of a, the turning point of y is equal to g of x. So basically what this means is we want the coordinates of the turning point of g of x, and g of x is right there. Now, this is not a beginner tutorial. This is for someone who knows the fundamentals of functions, cubic functions, quadratic functions, sorry. Yeah. So this is for someone who already knows some basic formulas like finding the formula of the x coordinate of the turning point, which is minus b over 2a, and so on and so forth. Okay. So what we are going to do now is we are going to copy this. Just copy this. And we're going to solve it here at the bottom. So now we want the turning point of g. So I'm going to write down my solution there. So this will be my solution page. Now, if you want this document for reference, please do state so in the comments. So this will be my solution page. First, I'm going to paste the function right there. Just put it there. I'll make it a bit smaller. And what I'll also do is I'll copy this because I will need this. Copy this because I'll need this. I'm gonna bring it down here as well. All right, so we've got this right here. Now, to find the coordinate of the turning point, as I said, how I approach things is I normally go for so I'll write the answer in green. So what I normally do is I normally go for the x value of the coordinate, then solve for the y. So the x value of the coordinate of the the x coordinate of the turning point is given as x is equal to minus b over 2a. Now remember, the equation of a power, in this case g of x, would be ax squared minus bx plus c, something like this, or plus bx plus c. It doesn't really matter with the sign conventions. So okay, we'll use this for the sake of simplicity. This is what we're gonna use. So what we have to do now is we have to expand this g of x and write it in this form right there. So what's gonna happen now is we're going to multiply the 1 over 3 into the equation. So we have here g of x is equal to, now if we can check there, how do I make this thing disappear? Oh, technology. Okay, disappeared for a minute. Doesn't want to disappear anymore. Okay, disappeared. Right, so we've got 1 over 3 there. So we'll take this negative 2 over 3 x squared plus 20 over 3 x minus 20 over 3, right? And that would be the expanded version, or the expanded version of our formula. So now we can apply this equation, x is equal to minus b over 2a. where x would be. Now, the value of b is this guy. What are you doing? The value of b is this guy, the 20 over 3. Now, that would be minus 20 over 3 times 1 over. Now, what is 2a? So 2 is just a static number, and a is negative 2 over 3, right? So we are here, and this looks complicated, but it's very simple. Just follow along with me. So what happens now is we do simple arithmetic, right? So this cancels out with that guy. And then what we'll be left with is negative 20 over what, negative 4. And that will just give me 5. So the x coordinate is 5, right? But remember, we want all the coordinates. So we want both the x and the y. So what we're going to do now is we're going to substitute in this 5 back into the original equation. So we can either substitute it into this equation, or we can substitute it into that equation. Now, for simplicity's sake, I would want to substitute it back into this equation. So what I'm going to do now is I'm going to copy this again. And I'm going to paste it over there, because I'm going to use this equation just now. Now, remember, we sub 5 into g of x. So I think I should just put that as a step right there, so that you guys don't forget. So now we are going to sub x is equal to 5 in g of x, right? So this is our step 2. All right, so what we'll get is g of 5. Remember, x is equal to 5 is equal to 1 over 3 negative 2 times 5 squared plus 20 times 5 minus 20. We close that there. And then now we just solve for this. So what I'm going to do is I'm just going to put this in my calculator. And then, in fact, let me do it this way. I need to have my notability there. Then I'll have my calculator just by the side. Bingo. Right. So just have it there by the side. Right. So what's going to happen now is simple mathematics. So negative 2, 5 squared plus 20, 5 minus 20. Right? And then what we'll get is 10. So now we know that, sorry about that. So now we know that the value of g of 5 would give you 10. Therefore, the turning point A is 5 and 10. And that's your final answer, right? All right, guys. Let's go on to question 2. Funny story. I actually recorded this the first time and my mic was off. So I'm literally recording this the second time now. Ish. Anyway, question 2. Question 2. What do you want? Question 2. Determine the coordinates of B, the point of intersection of the graphs. All right. So B is where the graphs meet, right? And one thing to note about the intersection of the graphs, right? At the point where they intersect, so at the point where the graphs intersect, intersect, I think that's how you spell it. X, so both x and y values of the two graphs are equal. of the two graphs are equal. All right, so both the x and y values are equal. Perfect. So now, bearing that in mind, we have to equate the two graphs, f of x and g of x. So f of x now would be equal to g of x. And what is the value of f of x, or of g of x? That's the value of g of x, and the value of f of x is x squared, right? Just verify. Yeah, it's x squared. Right, so what we're going to do now is we're going to equate, get the x value, then substitute the x value into the original equation to get the y values. So it's going to be x squared should be equal to 1 over 3 times negative 2x squared plus 20x minus 20. For those with fancy calculators, this is all you need. What you can just do is you can just equate this into your calculator, and then it will give you your answer, right? But we are going to do it the long way. So we'll multiply 3 both sides, and that's going to give us 3x squared minus 2x squared plus 20x minus 20. Then what's going to happen now is we're going to equate all of this to 0. So we'll get 3x squared plus 2x squared minus 20x plus 20. All of this is equal to 0. This will give us 5x squared minus 20x squared plus 20. All of this is equal to 0. Divide everything by 5. That will give me x squared minus 4x plus 4, not 5, plus 4, which is equal to 0, right? And then we open our brackets there. X 2, and that's going to be negative. So, sorry. So the solution will be x is equal to 2, okay? Right? Okay, so we're good on this part, right? So remember, this is the point of intersection. We have the x value, we still have to get the y value. So now we can sub in x is equal to 2 in maybe f of x to make it simpler. So now f of 2 would give you 2 squared, and then f of 2 would give you what? 4, right? So that's what we get. Right. So the point of intersection B is what? 2 and 4. Cool. Now let's move on to question number 3. What does question number 3 require? Question 3. Show that the gradients of the two curves are equal at B. Right. So I have to show that the gradients of the two curves are equal at B, right? So what that means is basically that we have to show that when we derive these two at point B, we get the same y value, basically. That's what they want. Okay, so this is quite simple. So what happens is we derive f of x. So to show, let's do this. To show that the gradients are equal, right? Step 1, derive both at B. So that is at x is equal to 2, okay? So let's do step 1. F prime of x would give you, okay, so f of x, let me not skip some steps. F of x is x squared, right? Then f prime of x would give you what? 2x, okay? Now let's move over to g of x. g of x is this guy, right? Okay. Oh, flip, no, shouldn't have done this. Should have done it this way. G of x is that guy. Yes. G of x is that guy. And g prime of x is what? 1 over 3. That's going to give you negative 4x plus 20. Okay? Yeah, that's fine. All right. So now what we do is we have to substitute in 2 for both. So sub x is equal to 2. Now, if we get the same returning value, so if we return the same value for x is equal to 2 for both, that means the gradients are equal at b. So we'll start with f prime of x. So we'll get there f prime of 2, which is going to be 2 times 2. Then f prime of 2 will give you 4, right? Okay, now let's move over to g of x. So g prime of 2 would give you 1 over 3 times negative 4 times 2 plus 20, right? And then g prime of 2 would give you, the value of this would be negative 4 times 2, that's 8. That's negative 8 plus 20, that's 12. 1 over 3 times 12 would give you 4. So I'm just going to bring this down a bit. So this is just going to give you 4. Now, since f prime of 2 is equal to g prime of 2, which is equal to 4, the two graphs, the two gradients, or the gradients, let me just say the gradients, of the two graphs are equal at B. Okay? Awesomeness. This is good. I like this. I like this very much. Okay. So now moving on to question, what question was this? Question 3. Okay, so I'm moving on to the last one. Question 4. Find the equation of the tangent to the curves at B. Okay? Now, to find the equation of the tangent, so question 4. So the equation of a tangent is given as y minus y1, which is equals to mx minus x1, right? So what is the m of the tangent? And remember, we already got m, but we can do it again. So to get m, we'll derive one of the two equations. So f of x is equal to what? X squared, right? We'll derive this, and then let's see. So it's going to be f prime of x, which is just going to give you 2x. And then substitute in, after deriving, substitute in the x is equals to 2. Remember, we want the gradient at that point, okay? So we have to substitute in the x value to get the gradient. So f prime of 2 should give you 2 times 2, and f prime of 2, which gives you 4, okay? Cool. So we know what the gradient is now. The gradient is 4, okay? Now, what we can do is we can also sub in our point B into the equation of y, right? That is the equation y minus y1 is equal to mx minus x1 to get the the equation, right? So now let's do the stuff. Remember, b is 2 and 4, okay? So y minus 4, which is equal to, what's the value of m? M is 4. So 4, open the bracket. What is x? X minus x1, which is just 2, right? And then we solve for that. Y, which is equals to 4x minus 8 plus 4. And then y would give you 4x minus 4. And that is the equation of the tangent. Now we've come to the end of our lesson, guys. If you haven't, please like and subscribe. And I promise that I'll be uploading such videos, every week. I'll upload at least one video every week, one mathematics video and one physics video every week. So if you're interested in content like this, definitely hit the subscribe button. And yeah, guys, as you know, I've got a tutoring company where if you need one-on-one assistance, you can just DM me on my Instagram, and then yeah, we can look into helping you out with that. We do offer contact lessons as well as online, so we are very flexible in that front. Okay, guys, I'll check you in the next one.